All right, so remember the graphs that we did a couple classes ago? We got the cosecant, secant, and the cotangent. So, you know, you have your pink card that we did those on. I just did little refreshers here. Remember cosecant goes with sine, so it's these like parabola shapes coming off the sine graph. Secant goes with cosine, so it's kind of scooched over and the parabola shapes are here. And then cotangent goes reverse of the tangent, but look at the asymptotes 0 and pi. And so you know that the period of these two guys is 2 pi. Period of cotangent is pi. And some other things to note. So look at the asymptotes here, 0, pi, and 2 pi. And then over here, it's negative pi over 2. And what would this one be? This would be 3 pi over 2. And this one is pi over 2. All right, so those are going to be kind of important because when we do our graphs and when we figure out where everything is, you know, 0 and pi are going to be like our boundaries of the graph. Over here, it's going to be negative pi over 2 and positive 3 pi over 2 are going to be our boundaries of the graph because that's where like kind of the first graph is. It's 2 pi wide, but that's where they are. And then this one's going to be 0 and pi. All right, so it's 0 right there. Okay, so just to kind of note that when I'm talking about it. All right, so here we go, this first one. So my first equation that I'm going to graph, or as an example, is y equals the cotangent of 1/2, and then x minus pi over 2, and then plus 3. So what this does for me, the plus 3 moves me up 3. My amplitude, we'll just go ahead and say 1, even there's no change out front, and I know amplitude doesn't really do a lot for us here. But let's go ahead and do my new midline. So my new center line is up at 3. So I'm going to go across here and go across here. All right, so there's my new center. And cotangent, you saw on the last page that the normal first two asymptotes are 0 and pi. So that's what I'm going to use to do my changes. The period is normally pi, but there is a 1/2 in front of the pi, or in front of the x, so 1/2 pi over 1/2 turns into 2 pi. Reflection, no, and it is going to the right by pi over 2. Okay, all right, so we take this 1/2 and x minus pi over 2. We're going to put it between 0 and pi. Now we could also graph this just like kind of logically. What happens here is that my graph is going to get condensed, so the period of this thing is going to be switched into, or actually going to be expanded into 2 pi. So my graph is going to go from here out to 2 pi. So it used to exist between 0 and pi, and now it's going to exist from 0 to 2 pi. And then we're going to shift everything to the right by pi over 2. So you're going to see that we're going to actually end up starting right here to right here. Okay, so you'll see that come out, but you can also just kind of like do this logically. You don't have to necessarily do it this way. All right, so I'm going to multiply everything by 2 here. So to get rid of the 1/2, so it'd be 0, x minus pi over 2, and 2 pi. Then add 1/2 pi, so pi over 2, and 2 pi plus 1/2, so it's 2.5, so it's 5 pi over 2, or 5 halves. All right, so there we go. There are my asymptotes. So I'm going to have an asymptote at pi over 2 and 5 pi over 2. So just like we kind of talked about. All right, so the center will be where it crosses that's my new x-axis in a way. And so when I draw the graph, remember it's the reverse of tangent. So it comes here, goes across, and goes down. And so I can see that this is, this space is 4 spaces wide on my picture. So I'm going to go ahead and draw another one. 1, 2, 3, 4. Right here, and just do another one. So come across and go. All right, and we could even do another one. 1, 2, 3, 4. All right, so you can see it's really important to have like, you know, nice graph paper that you're kind of working with, that's kind of marked. It makes your job a lot easier, and so kind of helping you out, giving you those. All right, so we'll go ahead and do another one, and then we'll check the 2 of these on Desmos. Okay. All right, so this next one, y equals negative cosecant of x plus pi over 4, and then minus 4. All right, so now cosecant. Remember, cosecant is the reciprocal of sine. So you can always do this. You can always imagine you have a sine function, but look at this negative right here. It's upside down. So I'm going to draw a sine function upside down as my basis. All right. So what's going to happen is we're going to have parabolas coming off of this, right? And then I have my asymptotes in the center here. But this is going to get moved over to the left, but that's just our kind of like our basic to kind of go off of. All right, so let's see. Amplitude, so no amplitude change. Reflection, yes. Period is still 2 pi because there is no change in front of the x. I'm going to go left, pi over 4, and vertical shift down 4. All right, so I do have like a new x-axis, so I think I will draw a line down 4. Whoopsie, there we go. Okay, and I can go ahead and mark the fact that remember that there's no amplitude change. So this graph is going to stay between -3 and 5. Actually, I'm sorry, the cosine graph or sine graph would have stayed between there, but the cosecant graph is going to stay outside of there. So before we used to stay within these lines, we would stay and do stuff in here. Now we're going to be above them and below them. So we're going to stay away from that section in the middle. Okay, so you could actually kind of just do this by thinking about it. You could say to yourself, well, I was going to start my graph. I was going to be down here. My asymptote was going to be at 0 and also 2 pi and also pi. So 0 and 2 pi, those get shifted to the left by pi over 4. So let's just shift them to the left by pi over 4. So that would be like right over here. And 2 pi was the last one, so that's going to be to the left by pi over 4, so here. All right, now do remember what we just did is we covered the front and the back. So we also have one in the middle because, you know, this has to have a downward parabola and an upward parabola. So right in the center of this area, if I go right in the center, 1.5, 1.5, okay, it'll be right here. At 3 pi over 4 actually, because right between 90 and 180, you know, this is 90 and this is 180, so is 135 or 3 pi over 4 if you had to figure that out. Okay, and then so from there we are just drawing our graph. Remember, this is kind of like my basis right here, so I'm going to go down and in the center of this first little section, so the center would be like right there, and I'm going to point that guy pointing down. And then in the next section, I'm facing up. So in the center of this section will be right here and point that guy going up. Okay, so, and we'll continue on in a minute, but I wanted to show you that you could take x plus pi over 4 and put it between 0 and 2 pi, the outermost asymptotes, and we take away pi over 4 from everywhere. So this would be negative pi over 4. And 2 pi minus pi over 4 would be like 8 over 4 minus 1 over 4, because 2 pi is 8/4. So 7 pi over 4, which is exactly what this place is right here. Okay, this one right there. This guy. All right, so let's draw some more. So when I look at this space that I've drawn, it is like 1 in the middle and then a half on either side. So the next one would be here. That's my next asymptote. And my next one there. And go back a little bit there to the left. So the next one would be here. And we'll just do like one more. There we go. All right, and then just keep repeating. On the right, the last one was up, so I'm going to go down in the center. And the next one up. And so, you know, what I'd be looking for is this point. You know, is it right there in the middle? Is it on that line? I know the rest of it's kind of, you know, sloppy or whatever, but, you know, you could definitely tell me that where that point was right there if you had to. Okay, so let's go check these on Desmos. Now, typing these in the calculator is a little bit more annoying, so I'll show you them on Desmos real quick, but here's our cotangent one. So, oopsie, there's my cotangent. And so if you check on your paper, we were correct. All right, and then here is my cosecant, and there it is. And so there we go. All right, and so you can see those asymptotes. Okie doke. So let's see, next one. So the next one we're going to do is going to be y equals 3 secant of x over 3 minus 2. So finally we have an amplitude change. So I'm going to say 3 is the amplitude, even though it's kind of like a different meaning here. The period is 2 pi divided by 1/3. There's a 1/3 in front of there, so that multiplies or divides, you could say, I guess, to 6 pi, however you want to think of it. There is no phase shift. We're going down 2. And reflection, no. So before, when you would do this with like a sine function or a cosine function, think of that. We would move our x-axis down 2, basically. So we'd be like kind of like down here. This would be like our new center. Okay. And so then we would say to ourselves, oh, the amplitude's 3. So that means that to me, I was going to stay up 3. 1, 2, 3. It's going to stay between here, 1, 2, 3, and here. So before, remember, I would be staying between these things. All right, but now I'm going to be up here, down here, up here, you know, things like that. So I'm going to stay outside of this area. All right, so let's see about our asymptotes. So secant. Secant is the reciprocal of cosine. So cosine looks like this guy, like this. All right, remember cosine comes down to there because I want to see where the asymptote is. So I need to know where cosine is 0. So that happened right here at negative pi over 2. And it happened again for the last time right here. So remember, cosine was finishing right here at 2 pi, but right here at 3 pi over 2 was that other asymptote. Okay, so remember, if you think back, oops, go back to our original graph, what we're trying to come up with is these two things right there. Okay. All right, so let's see. We want x over 3. My first two asymptotes were negative pi over 2, not my first two, but my outer two, I guess, and 3 pi over 2. Okay, so I'm going to multiply everything by 3. So this becomes negative 3 pi over 2, and this becomes 9 pi over 2. So it really stretched it out, okay? So 9 pi over, well, negative 3 pi over 2 is easy because that's on the graph right here, negative 3 pi over 2. So right here, there's one asymptote. Now, the other one is at 9 pi over 2. So remember, 4 pi is 8 pi over 2, right? Because that's 4 pi. And so 9 pi over 2 would be this next one. We're just going to make it right here. That would be 9 pi over 2. Okay, so that's my last asymptote there. So remember that that's this space. So I also have another asymptote in the center of this space. So the center of this space, let me see. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces wide. So 6 spaces in, right here, I'm going to have my other asymptote. And then I can go to the left and I can say 1, 2, 3, 4, 5, whoops, 1, 2, 4, 5, 6. There's another asymptote right here. Might as well get everything because, oh, wait a minute, is that too far? No, that's right. Okay. All right, so let's go ahead and draw this in the center of these areas. So the first area is this guy right here. So in the center of this area, I'm going to have a parabola facing up, and then the next one down on either side. Okay, so I'm just going to, whoa, whoops. I'm going to go to here. Remember, it's where I'm starting, where I face up. And then the next one is in the center, and I'm going down. And on the left, I will do the same thing, center going down. Okay, and you should see that this space right here should be 3 pi or 6 pi wide. And if you count it, if you do 9 pi over 2 minus negative 3 pi over 2, you get you get 12 pi over 2, which is 6 pi. Okay, all right, last one here. So my equation is going to be y equals 4 cosecant of 2x minus pi plus 1. All right, so amplitude 4, reflection, nope, and vertical shift, yes, up 1. So from those things, I can kind of do what I did before and, know that my new center is going to be here at 1. And know that I am going to be 4 up and 4 down from that. So 1, 2, 3, 4, 1, 2, 3, 4. And just like I said before, I used to be inside this space, but now I'm going to be outside of it out here. Okay. All right, so time for the asymptotes and the period and all that. Well, I can tell the period right now. because period used to be 2 pi, but I'm dividing that by the 2 in front of the x, so the period is pi, so it's getting squished in. So what used to happen in this length of time now happens in this length of time from here to here. All right. Let's see, the phase shift. Well, remember you got to get that 2 out of there. So take it, divide it by 2, so you get x minus pi over 2. All right, so it goes to the right by pi over 2. Okay, so cosecant is all based on, I'll just finish everything else. Cosecant is based on sine, right? So sine looks like this. And we are going to then know we have asymptotes here and here and here. And when we do our graph, it'll be coming off of the humps there. Okay, so this thing gets squished in. So if you kind of mentally think about it, this guy right there is now pi, and we're going to move everything right pi over 2. So that's going to be here, and the other part's going to be there. Okay, so everything got shifted over to the right. And that's basically all you would have to do to start drawing this thing. But let's go ahead and do our asymptotes the old-fashioned way as well. So I would take the 2x minus pi, put it between 0 and 2 pi. Because remember, that's where we were, 0 and 2 pi right there. Okay, add pi, so I get pi and 3 pi. Divide everything by 2, so I got pi over 2 and 3 pi over 2. Okay, so pi over 2 and 3 pi over 2, those are my asymptotes. And remember that they are the outermost asymptotes, so I still have another asymptote right in the middle. Okay, so right there. Okay, so this is going to be really small, but here we go. So my first one is facing up because this was not reflected, so I will be starting here in the center and going up. And the next one facing down, so here in the center of that section, going down. And then you basically just continue it on. So next one, up. The most annoying part is drawing the asymptotes. And then the next one, facing up. And down. All right, over on the left, I think I'll do some of those. So down. So like you could tell that this would be at pi over 4 comma negative 3. All right, so like that point right here, you could write pi over 4 comma negative 3. You would know that that's what that is. You would know that this point is at, let's see, I'm sorry, let me do the next one. Let me do this one. That would be 3 pi over 4 comma 5. All right, like you would know that point. All right, and then if I want to keep going to the left, let's see, the next one would be up here. And then, of course, you could draw your asymptotes on there. Basically, every line is an asymptote. Okay, so that's enough just to get the hang of it. All right, so let's look on Desmos and see this. So the last one we just did is this one right here. So see how it's all tight together? And if I kind of zoom in, you can see everything. Okay, and the other one we did is right there. See how that one was nice and fat, so you have it on your graph right there. And if I take this away, you can maybe see more of it, but you can see the asymptotes clearly at 3 pi over 2 and negative 3 pi over 2. Okay, and you can even kind of zoom out. Well, then you kind of lose your asymptotes though. All right, so one thing also to point out in Desmos, you see how let me turn these guys off. I just want to point out in number 1, see how to put that 1/2 in front with double parentheses. So there's no other way to type it in Desmos, so it's kind of annoying a little bit, but anyway. All right, that's it. We'll practice these next time in class.